In this video, I'm going to show you how to run an independent samples t-test. So we are going to use the data set that we used from the previous video. Now we see the first column here still is gender, and we have only two groups, one being male, two being female. And the second column here, we have a quantitative variable that's continuous from 0 to 100, measuring a participant's stress level, 0 being no stress at all, and 100 being extremely stressed. So the question here is, what is the difference, or is there a difference between male and female participants in terms of their stress score? To answer that question, we will go to our favorite tab here, that's Analyze, and compare means. We will do an independent samples t-test. Okay, here we have stress as a test variable, and the grouping variable is gender. So with grouping variable here, sometimes you have a grouping variable that has 3 or more categories. So if you want to compare two of them, you have to define the groups. So when you click define group, you will name group 1. So 1 is male, and group 2, I put 2 as female. So continue. And we don't have to worry about the options because it only just tells us that we are running it on a 95% confidence interval. And we can click out of that and click OK. So the output tells us a few things. One, if you remember from the previous video, we have the breakdown by category. So male is 24, and female we have 16 participants. And we have the means for them, we have the standard deviation, we have the standard error. And in the next table is our main event here. So the first part, we see there's something called the Levene's test for equality of variance. This basically tells you if the variances are equal or not between the two groups. And what we want here is equal variance, because it's sometimes it's hard to translate when the variances are not equal. But SPSS provides you both answers for equal and not equal. So here we have a significant score of 0.507, which means, this is a little tricky here, this means that we can assume equal variance because the null hypothesis here is that there's no difference between the variances of the two groups. So the next part is our t-test results. So the first one here, the first column here on t is our t statistics. Here is being 2.727. And the significant score, which is the p-value associated with that t-score, is 0.010. So the two important components of a t-test, one is the t-score, but by only having that t-score, you're not going to be able to tell much unless the score is extremely big or extremely small. So if you just have a 2.7, normally people wouldn't be able to tell if this is significant or not. So you are going to need to refer to the p-value, which is the SIG score here. Again, here, if we're using 0.05, then this is significant because this is smaller than 0.05. We're only having a 1% chance of making an error. So the conclusion for this independent samples t-test is that there is a difference in terms of stress scores between male and female. And since male is group 1, if you remember from a few seconds ago, male being group 1 and female being group 2. So the t statistics is positive, and the mean difference is also positive. That means group 1 is larger than group 2 because the function here is 1, group 1 minus group 2. So if group 1 minus group 2, we have a positive outcome, then that means that group 1 is significantly higher than group 2. So additionally, in addition to male and female being different in terms of stress scores, we can also conclude that male participants in our sample have higher average stress score. Okay, and there you have it. This is our independent samples t-test.